Welcome to Bodhi Unified Flow. We're here to simplify complexity and amplify performance. Today, we're diving straight into a massive shift happening right now in our industry. We're unpacking the blueprint revolution, specifically giving you a 4-year roadmap to civil engineering mastery for BE and BTech students. We're calling this the Green Horizon. It's all about sustainable, self-sustaining construction, which is, without a doubt, the future of the industry. In this explainer, we're going to zero in on eco-friendly materials like fly ash bricks, mind-blowing off-grid living solutions, and exactly how we can slash the carbon footprint of the built environment. Let's get into it.
Here is our game plan for today. Section 1, the Green Horizon Vision. Section 2, eco-friendly material innovations. Section 3, off-grid living solutions. Section 4, reducing the carbon footprint. Section 5, the 4-year civil roadmap. And finally, Section 6, our summary and references.
So what are you actually going to get out of this? Well, by the end of this session, you're going to understand the science behind eco-materials, specifically pozzolanic paradigms. You'll explore how decentralized utilities like atmospheric water generation actually work in the real world. You'll firmly grasp the life cycle assessment metrics we use for carbon footprinting. And, maybe most importantly, you'll be able to map all of this directly to your 4-year BE or BTech mastery roadmap. Okay, kicking things off with Section 1, the Green Horizon Vision, the built environment structural evolution. The stakes we are dealing with here are absolutely massive. Right now, the built environment is responsible for a staggering 40% of global energy-related carbon emissions. Let that sink in for a second. Almost half. This isn't just a tiny inefficiency we can ignore, it's a structural mandate for a complete overhaul. We can't keep building static, draining infrastructure. The Green Horizon demands a shift where our buildings are actively engineered to act as carbon sinks. And honestly, the economics reflect this urgency perfectly. The global sustainable construction market is projected to hit over 1.3 trillion USD by 2034. That is a massive 13.6% compound annual growth rate. This boom is being fueled by tightening global regulations and a massive surge in ESG investments. So, for a modern civil engineering student, mastering this space isn't just about saving the planet. It is quite literally your biggest career advantage. Moving right along to Section 2, eco-friendly material innovations, re-engineering substrates for a low-carbon future. Let's look at a direct, head-to-head matchup, fly ash bricks versus your traditional burnt clay bricks. Fly ash is actually a fine byproduct of coal combustion. By using the pozzolanic reaction, where fly ash reacts with calcium hydroxide and water, we get a dense gel that provides remarkably high compressive strength and low water absorption. Plus, because we completely skip the energy-heavy firing process needed for clay bricks, fly ash bricks give us up to an 80% reduction in carbon footprint. In fact, in places like India, utilizing this industrial waste is already a mandatory regulation near power plants. It's a total game changer. But we aren't stopping at fly ash. The innovations happening right now are wild. Take geopolymer concrete. It uses an alkaline activator and completely ditches cement clinker, which is a massive source of global emissions, reducing CO2 impact by 40 to 80%. Or what about literally growing our buildings? Mycelium composites use fungal root networks to bind agricultural waste together, creating insulation with a negative carbon footprint. And then there's biochar concrete, which uses pyrolyzed organic waste to actively lock away up to 3 kilograms of CO2 for every single kilogram used. It's incredible stuff. All right, on to Section 3, off-grid living solutions, the engineering of utility autonomy. To build a truly self-sustaining structure, it has to function independently. For water autonomy, especially in dry areas, we use atmospheric water generation, or AWG. It's a brilliant 4-step process. First, it extracts ambient humidity from the environment. Second, it cools that air below its dew point using advanced refrigerants or desiccants. Third, that moisture condenses into liquid water. And finally, step 4, it purifies that water through multi-stage filtration and UV sterilization. We are literally pulling clean, potable drinking water right out of thin air. Now, when you pair AWG with localized energy and waste systems, you can completely cut the cord to municipal grids. For energy, we're talking solar microgrids with PV arrays, battery storage, and smart management systems. For waste, the building essentially digests its own output. We use waterless composting toilets for aerobic decomposition and anaerobic biodigesters that break down organic waste to actually produce usable cooking biogas. Combine that with constructed wetlands for greywater treatment, and you're recycling up to 35% of the building's domestic washwater right there on site. Let's transition to Section 4, reducing the carbon footprint, frameworks, metrics, and global standards. You know, just saying a building is green doesn't cut it anymore. We need hard data. And to master life cycle assessment, you have to understand the difference between embodied carbon and operational carbon. Operational carbon is exactly what it sounds like, the emissions from heating, cooling, and lighting the building while it's being used. But as our grids get cleaner, embodied carbon is becoming the main focus. This is the massive chunk of upfront emissions from extracting raw materials, manufacturing them, and transporting them to the site. Today, about 13% of all annual global emissions come strictly from this upfront embodied carbon alone. So, how do engineers track and slash these emissions? We use powerful digital tools and aim for rigorous global certifications. The EC3 tool, for example, is fantastic. It analyzes supply chain emissions right during the procurement phase. Once the project is built, validation is key. You've got LEED, the globally recognized point system from the US, BREEAM out of the UK for deep lifecycle assessments, GRIHA, which is uniquely tailored for India's climate with a huge focus on passive cooling, and EDGE, which demands a strict minimum 20% reduction in resources. Which brings us to Section 5, the 4-year civil roadmap, integrating the green horizon into your BE or BTech. So how do you actually learn all this and become an expert? This timeline lays it out perfectly. Year 1 is your foundation, math, physics, and environmental ethics. Year 2, you get into mechanics and materials, studying fluids for those off-grid systems, and diving into fly ash and pozzolan science. By year 3, you're specializing, structures, geotech, and integrating LCA and carbon accounting into your designs. Finally, year 4 is your capstone design, where you bring the whole shebang together by designing a complete net zero infrastructure project, getting you fully prepped for licensure and the real world. All right, we made it to Section 6, Summary and References, bringing the blueprint revolution together. Before we recap, I want to show you this in action. Look at the Jhansi Net Zero Library in India. This isn't theoretical. This was built in just 90 days. It runs on 100% on-site renewable energy, uses AWG for its drinking water, and reduces its carbon emissions by a massive 85%. It is absolute proof that these sustainable concepts are highly scalable and ready to be deployed right now. So let's look at what we've covered today. We've mastered the science of eco-friendly substrates like fly ash. We've unpacked how to engineer true off-grid autonomy using AWG and microgrids. We've clearly separated operational from embodied carbon. And we've mapped out your exact 4-year academic path to sustainable civil engineering mastery. I want to leave you with one final thought to chew on. If our built environment can act as a carbon sink, literally sequestering CO2 through materials like biochar mycelium while generating its own power and water entirely off-grid, are we even just constructing static buildings anymore? Or are we, as future civil engineers, actually designing living, breathing ecosystems? For those who want to dig deeper, here are the references that grounded our explainer today. This first batch includes our core market research from Grandview Research and essential guides on carbon tracking from One-Click LCA. Next up, we have detailed academic studies on fly ash-based eco-efficient concretes and life cycle assessments. And finally, these sources document the regional ash utilization guidelines, those cutting-edge mycelium composite studies, and the real-world case studies we just looked at. Thank you so much for joining us here at Bodhi Unified Flow. Simplify complexity, amplify performance, master the green horizon, keep innovating, keep pushing those boundaries, and we'll catch you in the next explainer.